So this is a review of all of our conics here, guys. We started off talking about circles, that's the second one down. Then we moved on to parabolas, that's the one on the top there. And then last class was ellipses, which is the third one down. Today we're doing hyperbolas. So this is a review of everything that we've done since we started the unit. Now, what we're about ready to do is I'm about ready to give you guys some equations and ask you to graph them. Now, they all have pretty similar methods for graphing. They all usually have you start with H and K, right? And then from there you do something else. But they also have some differences. So it's important that when you're looking at the equations, you know what they are so that you know what steps to follow to graph them. Okay? So I need you to be able to look at the equation and know what they are. So let's go ahead and see what their distinguishing characteristics are. First of all, how is a parabola different in the equation from all the other equations? Do you guys see anything that stands out? It has an A, none of the other. Well, there's an A on the other one, but the A is outside of the Y minus K. Okay. Now going by those letters might be a little bit different because usually there'll be numbers in their places. There you go. Now, that's the one I like to focus on, is that only one letter is being squared. So I'd encourage you to write this down. Only one letter is squared. A parabola either has the x being squared or the y. All the other ones have everything being, the x and the y being squared. Okay? Now let's jump down to the hyperbola. There's something that's pretty unique about the hyperbola that none of the other two don't have in common with it. Do you guys see what makes the hyperbola unique? It's got that minus in there, right? Both ellipses and circles have those pluses in the middle. But a hyperbola has a subtraction sign. So a hyperbola is the one where both the x and the y are being squared, but there's a subtraction sign somewhere in there. So has a subtraction sign. Now the circle is going to be a little bit more difficult to distinguish from the ellipse. They both are squared, the x and the y, and they both have pluses. But there's another one. And now here you could say, well, on the ellipse they have denominators, right? Whereas on the circle they don't. That's not always going to be so obvious, and you'll see why when we do some example problems. Yeah? That would be another one that stands out, and it's kind of the same thing. It's equal to r to the second. But a lot of times you guys have seen where our ellipse is equal to a number and we have to divide it over first, right? So you're not going to know just by looking if it equals a number other than 1 if it's an ellipse or a circle. Because what we can do is we can also divide everything on the circle by r squared, right? And that will leave 1 over here. You guys might want to write this down with me. Now, what do you notice? They're almost identical, right? They both have x minus h squared plus y minus k squared equal to 1. But they're denominators. Now we can't just go by the letters because in the place of those, you can't say, well, this one has an R and this one has an A and a B. Because when we actually do these problems, those will be numbers. But what are you noticing about a circle? No, they may not cancel out necessarily. Here's what it is. Notice on a circle, the x radius is the exact same thing as the y radius. That's what makes it a circle. It's the same all the way around. Whereas on an ellipse, whatever you have under the x will probably be different from whatever's under the y because that's what makes it stretched and elongated. So, same denominator versus different denominator. Okay? So that's how we're going to go about distinguishing these conics in our minds. I'm going to give you guys like a mental map of how I kind of make my decision. I'll leave it up to you if you want to write it or not, but I think it's pretty helpful. Here we go. The first thing I do is I ask myself this question: are both letters being squared? If the answer to that question is no, what kind of shape is it? If they're not both being squared, meaning only one of them is, what is it? It would be a parabola, because a parabola is the one where only one letter is being squared. Now after that, though, let's say it is yes. We have some more decision making to make here. That leads me to a new question. My new question is it subtraction or addition? If it's subtraction, you're subtracting the x minus h and the y minus k. What is that? Which one has the minus between the x minus h and the y minus k? That was the hyperbola. And you're done at that point. You know what it is. However, if it's addition, we have to ask ourselves one more question. What's the question? Is it a circle or ellipse? And how can you tell by looking at the equation? The denominator, right? If the denominator is the same for both x and y, then it's a circle. If they're different, it's an ellipse. So, different or same denominator. If it's different, then it's an ellipse. If they're the same, then it's a circle. So that's kind of the mental process I go through when I'm looking at these and I want to see, well, what is this exactly? First of all, I look and see if they're both squared. Then I go from there. Put this to use. Okay, go ahead and write down your directions in number 1, please. So the directions are asking us to do two things. Decide what it is, and then from there I'm going to graph it. I might just ignore the graphing, but I'd like to spend the time reviewing the graphing, just to kind of as a review for you guys. So let's go ahead and get started here. First of all, are both letters being squared, or just one of the letters? Both. So I'm going to move to the right of my tree, and the next question I have to ask myself is, are the x part and the y part being added or subtracted? They're being added together, right? Since they're being added, we have another question to ask. Would the denominator be the same? Well, we don't have a denominator right now. So what would I do to make that denominator? Divide that 25 into everything. So if I divide 25 by itself, I get 1. This will be 25. This will be 25. Does anything reduce? So do they have the same denominator or different? And what does that mean when they have the same denominator? It's a circle. So let's go ahead and just graph this really quick. Let's first of all write down that it is a circle. Now maybe you guys can help me. How do you graph a circle? What do you do first? You plot your center, which happens to be what? 3, 0. And then I'm not going to put x radius and y radius because it doesn't matter. They're all the same on a circle. What is my radius? The square root of 25, which is 5. So 3, 0. My radius is 5. So I'm going to go up 5, down 5, left 5, right 5. Let's go through our questions here, guys. First of all, are both letters being squared? So it's not a parabola. Next question, are the x and y parts being added or subtracted? If they're both being subtracted, what does that mean? It's a hyperbola. And I need to graph a hyperbola. Let's go ahead and write down what it is first. Number 2, It's a hyperbola. What would I do first? Divide everything by 36, which would make a 1 here. And 36 is on the bottom. What's my center? And then my x radius and my y radius are both 6. So when we're graphing a hyperbola, what's the first thing I need to do? What is it? Plot your center. So that's 0, 0. And then? So use your x and y radii. X radius is 6 and so is the y. And what do? You make a box, right? It might be tempting to get confused at this point and try to make an oval, but remember, we're not doing an ellipse right now. We're doing a hyperbola. And then what do? Draw our asymptotes, right? And then what kind of a hyperbola is this? Left and right or up and down? Left and right, because the x is positive. Okay. Let's go through our questions now to determine what this is. Are one or both letters being squared? Only one this time, which means it's a what? Parabola. Now, that's the most different one. So, what do I do first when graphing a parabola, guys? We're not going to worry about the focus with this. We don't have to. We're not going to be that precise about it. We're going to find the vertex. There's no center, but there is a vertex, and it's the same. It's the h and the k. So my vertex is my h and k. What's my h? 1. And what's my k? 0. The numbers that are being subtracted from x and y, just like always. All right. Now this is where it starts getting different for a parabola. Now what? We don't need a directrix either. The a, right? Okay, that's part of it. But something else needs to happen before that. Because remember, our parabolas can be going to the left and right, or they can be going up or down. Let me ask you this. What is this one? Not quite. This is a horizontal parabola. Do you guys remember that whenever the y minus k is being squared, it's horizontal, and in this case that's what we have. The y is being squared, so it's a horizontal parabola, which means that it's either left or right. Now, how do we know which it is? We have to look at the a. What is my a? It's negative. Since a equals a negative half, it goes which way? It goes left. So it's this one. So now we're ready to graph it. Plot your vertex over 1 up none, and it's opening up to the left. Here we go. So last one. Are both letters being squared or just one of them? Both are. Now the next question, are they being subtracted or added? Added. So we have one more question to ask. Will they have the same denominator? We got a little bit of math to determine that. If I divide this side by 36, I get 1. If I divide this side by 36, the 4 will go into 36 9 times. Do they have the same denominator? No, which means, what is it? It's an ellipse because they have different denominators. Now, I'm not going to graph this because we just got through doing it today and we're kind of running late on time. But I do want you guys to be able to tell what it is.